everyone, I'm Gina Doyle and I'm a senior product designer for the Runner Fleet team. The Runner team has been putting a significant amount of work into a new token architecture effort for runners, which you may have heard about, but if not, I'll leave a link in this recording so that you can access it. This will help make runners more secure and efficient. And this also led to some changes in the back end that would then need to be accounted for in the front end. That brings us here today for me to share insights from a research study that we ran about what we were calling runner machines. So with the new token architecture work, if there are multiple runners registered with the same authentication token, you will see these listed as machines in the database that all relate to a single configuration. You'll likely see this the most in auto-scaling scenarios. Although this makes the load on the database much smaller, we assumed that introducing the term machines and grouping runners and machines in this way would break mental models with users and cause more confusion. What we didn't fully understand was, how do users interact with machines today? We needed to validate the problem, so we took a step back from solutionizing and went to research. The best way to move forward was to meet with runner administrators who are using auto-scaling runners, which would be Docker machine or Kubernetes executors, and understand how their job to be done relate to the main runner fleet job to be done about managing runners. To give you a little bit of insight into what we were solutionizing beforehand, we had, let me stretch the screen out. We were listing the runner in the table and then saying if it had, indicating if it had machines by using the 2 and this icon, and then showing machine details in a drawer. We did end up using this for a little bit of the research sessions, and I will explain why very soon. So as we continue on, you may hear me use the term runner managers. A runner manager acts as a coordinator for auto-scaling instances and can create many runners when scaling. So each runner manager shows up as a separate runner in the runners table today, even if they have the exact same configuration details. Sometimes this can cause clutter in the UI because a huge number of them are registered at once, and maybe like only one of them is contacting GitLab. This was specifically reported in this issue that we don't unregister the old runner manager once a pod restarts here, but there's a number of comments saying that they just had a ton of runners registered, and it was difficult to find which ones were actually online. So for this study, we met with mostly internal GitLab team members since we manage shared runners for our SaaS customers, as well as one external runner administrator. And the sessions were formatted as a split between understanding how users interact and manage auto-scaling runners, highlighting any pain points that they're facing today, and then also asking them to complete tasks with that proposed UI that I was showing for runner machines. The reason why that we did this is because we wanted to give them a solution so that they weren't designing for us. So by providing that design, we could still allow them to go through tasks and see if the terminology and the design that we had come up with actually makes sense to them. We were ultimately able to obtain really great insights from the study that increased our confidence and our understanding of auto-scaling runner management, as well as which terminology is best to use moving forward. So as a summary, we did confirm that the job to be done for runner fleet do apply for auto-scaling and non-auto-scaling runners. We also found things like the term machines is confusing, and grouping runner managers is useful. And then the term runner manager is something that users are familiar with. So I'm going to start just jumping into these insights now. Starting with this first one, users need to compare data across runners, whether it is a runner, group of runners, or runner managers. This relates to the job to be done, and regardless of the type of runner, it's really beneficial to be able to compare data across those runners at once. So the recommendation here for us is to update those runner groups that I was previously showing in a drawer with what we were previously calling machines, we're going to update those to be expandable rows within the table so that you can see all of that data and compare it in one view. The next insight here is that runners are seen as runners, whether they are runner managers or not, or what we were calling runner machines. If runners have the same auth token, they're just considered a group of runners. Users see, and this is what their mental model has become based on what we've created the UI as for years now. They see runners as objects. So whether they're the agents that are actually running the job or they're the ones that are acting as coordinators, they still see them as runners. This leads us to kind of using this insight to determine where we're going to go with the terminology for the term machine. And then what we should update the UI text to be runners and runner manager rather than just machines. And we also found, like I was saying before in the summary, that users are actually really familiar with the term runner manager. And there's multiple customer blogs that are out there that mention that term. So we want to display that. We might as well just say it how it is because we use that term so often. Another insight is that a summary of statuses in a group of runners is helpful to get a quick idea of how they're performing and how they're configured. When it comes to if there is a group of runners, we want to be able to provide an overview very quickly of their statuses and then the configuration details that pertain to all of them. Example of status could be 2 of 5 are online, and then an example of configuration could be their tags. So the recommendations here is to make summary status stats number over total, so it's clear how many are in that group, and then summarize the data of the runner group in the parent row and in the runner details, and allow for each expandable row to contain single runner data. When I show you the designs, I think this will make sense a lot more. This next insight was a great one for us to pull out of this study that doesn't directly relate to the iteration that we're working on, but it is critical for an admin to see which runners are failing. So something I learned through this study as well is that runner failures are different than job failures. A job may fail because the test failed, and it should fail because the test in that case failed, but the runner ran that job successfully. When a runner fails, maybe it's due to a timeout or something like that, there could be actually something wrong with the runner or the runner configuration. And that's something that the runner admin would want to fix and want to know right away. So it is helpful for them to see which ones have failed recently or are failing so that they can fix them as soon as possible. A lot of users have set up alerts for when this happens, or maybe a developer, they report that their job isn't getting picked up, and that kind of like triggers the admin to look into this. But if we are able to just show that information right away, it will make that whole process way quicker. So I'm going to create an issue for this feature so that we can explore bringing this into GitLab. The next insight that we got here is that comparing runner machine memory or capacity enables admins to debug faster. So a lot of the things that admins can do in the UI, we don't pull in from external resources. They kind of have to go to those other places to find out stuff like memory, for example. But actually being able to see this and have insight into it can help them figure out why a runner is failing. Also, if these metrics were available over a long period of time, the admins could also figure out how to optimize their fleet and cut costs and make use of machine sizes more effectively. One of our runner teammates has already made an issue to start getting insight and visibility into GitLab for this. So I'll just be relating this insight to that issue. The next insight is about users using the runner UI. And this was actually a really cool thing for me to understand more just about their workflow with the current UI. So they seem to use the UI for high level insights into if a runner is misbehaving. And they're great. It's great at this high level because they can figure out if a runner is not working properly, like if the runner is offline or it's not running jobs. But then the next steps typically happen outside of GitLab, like debugging and the runner logs or some other system data that is not on GitLab. And I think we could investigate how possible it is to bring this type of information into GitLab. So I'll be creating an issue and exploring how we could do that. This next insight is about the project's runner view, which is something that we've heard multiple times before. So I'll just be relating this to existing insights and maybe bumping up severity of existing sus impacting issues. But the admin group views UIs are significantly more usable than the project view for the following reasons. One, summary stats are necessary to get a quick overview of your runners, and the project view does not have that. Two, it's difficult to find the runners that you want to manage in the project view. Three, specific runners that are available to be shared, which usually have the enable for project button next to them, they create a huge amount of noise in the UI, and it's difficult to then locate the relevant runners when they're listed. And finally, tons of runners are created using the Helm chart installation, and it makes it difficult to find which ones are actually online and running jobs. This is specifically difficult in the project UI because it's not easy to scan the statuses of runners. And then I think also just this Helm chart installation problem is a thing in itself. So the recommendation here is to, again, relate these insights to some insights that we already have about the project view and trying to increase priority in that area. And the last one here is something that would need further exploration if we want to continue looking into, but we did use a drawer to display runner details rather than using its own page to look at the details. And we found that it may make it easier to switch between runner details quicker and decrease the perceived loading time of those detail pages. Half of the participants were fine with the runner details being on a separate page. They actually mentioned specifically being able to focus in on the details versus half of them said the ease of switching between different runner details and not having to wait for another page to load makes the drawer beneficial. So if we want to keep exploring this, then I'll be running research specifically around using a drawer versus having the details on its own page and see if it impacts the user's ability to complete their main job to be done. So that brings us to the end of the insights. And now to show you kind of how this is shown in the UI based on that. So now you can see that I have indicated if a group of runners exists by including an expansion ability so that you can expand the rows and collapse them. And then you also get this other indication here that there's two, it's like a collection of runners. So I wanted to make it clear by adding that other indication that there's like a group here. You can also see the summary status updates that I was talking about. And then finally, when you expand this, these are each of the runners that are in that single, that are in that runner group. So in this case, you have two runners and this is their system IDs and then their versions so that you can still compare all the information that's necessary. And then as for when you look at runner details, we'll just still go with the full page for now, and we'll still be showing the information about the machines on that full page, but it won't be in a drawer until we further investigate that. And then lastly, what you can notice here is I've added a couple other indications of whether the runner is a runner manager or not. And we'll add a tooltip here so that it's clear what the definition of a runner manager is. And finally, one other thing that you can notice is that we summarize some of the metadata if there's a group of runners. So in this case, all of these runners have the same tag. They're both that they use Ruby as the tag. And then like they have the same description, but they're also associated with the same project and they're protected, but they have different IP addresses and they've run different jobs. They may have been created at different times, and they may have contacted GitLab at different times as well. So that is it there. I'm going to work on summarizing the insights into this GitLab issue. So feel free to check them out there and leave any comments if you have feedback. And I just want to say, if you're still watching, thank you to the runner team for having a ton of conversations about terminology as we were working through this. And then also thank you for having the patience to wait for me to complete this study so that we have more confidence. And I'm so happy that we have a lot more confidence than where we started so that we can actually successfully help our users. Thank you.